XM Cloud also changes the way that we approach the architecture and development of the more advanced implementations. Sure, if you're building a straightforward website with only editorial content, Sitecore XM Cloud and, for example, for Cell will offer you a great set of tools to put a professional website out without any custom development. Well, other than your JavaScript frontend, of course. But if you're looking to build a more complex website, like an e-commerce website or a portal, how would you want to cope with building the integrations and optimizations in a resilient, maintainable, and scalable way without the ability to rely on the, well, let's call it habits from the good old days, like the Sitecore item IPA and our custom Solar indexes? My name is Habraken, and I'm a technology director at I/O, and I've been working with Sitecore for over 17 years, and I'm very excited about the new architecture of Sitecore's composable world. First, let's briefly start out with the general architecture of a composable landscape when you're building with multiple components with different architectures. And I'm sure you've seen this hexagon image a lot. It's not only used by Sitecore, but by other tools as well, and that's because the composable world should be neighbor-friendly. You should be able to integrate with other components or packed business capabilities, as some people call them. And if you want to do that, integration is key. Being API first, or even some components can be API only. And you want a strong separation of concern to avoid overlapping functionality, but also to improve your maintainability. And of course, we have our decoupled front ends. But there's more to a composable architecture. Well, first of all, as I said, are going to combine or are able to combine different architectures, like your own microservice or a SaaS platform. But also, you're now open to use any language, tool, or system you like, as long as you work API first. And that's creating what we call a polyglot landscape. It actually doesn't matter a lot anymore if software is SaaS, what the actual architecture behind it is. And that's a great concept, but it also brings a few new challenges to the table. And that's what I want to talk about today. And for me, composability comes with a different development approach. And I see composable as the next step up from going headless. We all know that going headless decoupled our front end, but our Sitecore implementations were still like sort of a monolith, and we had our integrations going over the Sitecore platform. And when you go composable, you're actually decoupling all of the elements in your architecture. And the CMS is one of the data sources, like your other external data sources with maybe product data or maybe booking information. So you are really relying on standalone integrations. But there's another change that's very important in this image as well, and that is that your integrations are now pushed towards the front end. It's no longer the case that all your data is running through Sitecore, but you're connecting that from your front end. So that means that you have to carefully plot out the architecture of your composable landscape, and that you need to take some design considerations into account. But the first thing when you build a new composable architecture is selecting the right components. And before we go to seeing what the possible components are, I want to have a look at why did we actually deploy to Sitecore in the past. And with deploying to Sitecore, I obviously mean deploying our custom code, our custom implementation on top of Sitecore, which is something, as you heard multiple times today already, is no longer the recommended approach. Well, the first thing I think is because we're just used to it, because in the past, MVC forced us to integrate external data into the rendering, and with going headless and having JSS, we really didn't need to anymore. But before XM Cloud, we still, regardless of the fact that we had JSS, were doing that. And that led to us to create custom content resolvers and doing data modifications on the data that we are sending to the front end. We have our custom search indexes, obviously, to query specific content items, and we want to respond maybe to content and publishing events, hook into event handlers and do some changes to the data. For example, pulling in data from external data sources, like the product data or booking data or account data in a portal situation, but also maybe to redact user input, like if a user doesn't follow a certain name convention, we are going to change the name of an item, or in case of news articles, we maybe have a hierarchy with folders in the CMS that have a date field, and we just move over the content when a user creates it. All that kind of stuff we were doing to customize our Sitecore solution. Also leading to creating custom content fields and editing the experience editing UI. And for all the rest, that's what I could think of was the use cases. All the rest is just because we were happen to be already in there and just build a solution from there, but there's really no need. Well, for all of these, and I should say that this is out of scope for my talk today, it's not about integrating, but for all of the other use cases, there are better solutions. You can integrate with the front end, as I said, in a composable landscape. You can use GraphQL to query content or implement a search product like Sitecore Search, for example. And for responding to certain events happening in Sitecore, you can utilize webhooks. And even editing content in Sitecore is possible with the authoring API. And all the rest is actually not necessary. So as you can see, there's actually a lot of options to do everything that we did in the past on our Sitecore implementation, but in a composable way. And for that, you have to select the right components. But before I want to share a few of those components, I want to talk about integration flows. As I said, in the past, we used to route all of the content coming from external data sources through Sitecore. And that still might be a viable option. It still might be your use case, that's the best scenario. But you actually do not have to. If you do so, you don't want to have that logic onto Sitecore, but you want to have it in a separate microservice, and you want to use the graph authoring API for that. The other scenario, which is a way more clean architecture, is to directly call external data from the external data source from your front end. The third solution, and that's maybe a bit more complicated, but it's kind of my solution to work around the downfalls of the other options, is to create a sort of a hybrid approach. And with this hybrid approach, I'm not sure if the arrows are very, yeah, they are clear enough. They're light gray. That's always a gamble on bigger screens. And I can barely see them here. So the hybrid approach is, you could create certain content pages and content items in Sitecore if you need that. But maybe additional data can better be stored in an external data source and get it from there. And I think I have a good example of that later on in my talk. So that's a very important thing to assess when you start to design an architecture that utilizes external data. But in most cases, the recommended way is to just directly retrieve the content from your external data source. And as I said, you can also edit content items in Sitecore with the authoring API. So there's actually two APIs within XM Cloud, or even more, but two categories. We have the Edge and we have the authoring API. And also, and you will find that it's still available or present in XM Cloud, the item IPA. And that's what we've been using in the past. But you actually don't want to build on top of Sitecore anymore. The item IPA requires your code running on XM Cloud. And that means that you have to deploy custom code to your XM Cloud instance. But it doesn't make a lot of sense. Maybe when you're redacting input from a user that's creating content items, that might be a scenario. But in most cases, creating content in Sitecore involves external dependencies. You have to get the content from an external data source, and you're also going to integrate that, and then you're on a kind of a domino effect towards a more monolithic approach. So you don't want to do that. What you do want to use is the authoring API, and that's one of the APIs that's offered next to the Experience Edge Delivery API, where the Delivery API is focused at content delivery and thus optimized for read performance, exposing things like your cached content, but also your layout snapshots, personalization, and media. Your authoring API is focused at managing and authoring content. And it provides a full CRUD operation capability, including publish, and you're actually interacting with the raw data model. Note that these two have a different schema, and I'll show you an example of that in a minute. But there's actually two more APIs. We have the token API in Experience Edge, which is used to create a token for authorization, and the Edge Admin API for actually it's kind of a CRUD for creating webhooks, which is also very useful when creating integrations. So in a sense, we have Edge and we have authoring, but if you look at it from an integration perspective, we have the delivery APIs, because token is needed and used for creating your delivery API consumption. And we have the integration APIs that you can use to integrate with and to create functionality with. And these are the ones that you want to use, preventing that you actually need to deploy anything to Sitecore. And I have some query examples. As I mentioned, the Edge and authoring API both use completely different schemas. And just be aware that you cannot exchange them. If you're browsing through Docs Online or searching for help, and I know this because I've bumped into this myself, you just try out an example, it just doesn't work. So always make sure that the correct API has been referenced when you're checking something. The approach is different. Edge queries on a path, whereas the authoring API obviously focuses more on IDs, but also mentions the index. I'm not sure how long this is going to be in here. I've seen the talk by Liz, so things might be changing rather soon, but this is how it is right now. And it's a logical thing, because I didn't really feel it as like being difficult or bad, because it's a different approach and a different way of thinking when you utilize these. And going to code, you can quite easily build a query object around that GraphQL query. This is an example that just publishes a single item based on its ID to all of the languages that I provide. And this allows you to use and run this code on a microservice separately from XM Cloud, and you're able to publish an item from externally. And we have even built some helper classes around this, so we can do all the create, update, delete, and publish utility or functions from our microservice connecting with the external data source. So whenever you're going to use the authoring service, think of, do I really need to use the authoring service to push data into Sitecore? Because as I said, the recommended approach is directly retrieving the content from your external data source. But if you have to, you can use the authoring and Edge admin API and check if you're at the right schema. Now, as I said, also webhooks are available to create your event handlers that we have been used to in the past to integrate and publish to Sitecore. And there's 3 types of webhooks. We have event handler webhooks, which is to receive information about system events. And then we have 2 others that are purely focused on workflow states. That's the submit and the validation action. And with this, you can not only retrieve information about workflow state changes, but also hook into them and let third-party maybe endpoints or APIs decide whether to approve or reject a certain workflow state change. So you can even do some external validation. That works perfectly fine, but obviously that's only for workflows and not for system events. And we do have a lot of system events. Not going to go through them all, but you can see, you can almost observe any change of an item in Sitecore, and you can also follow the publish events. And it's up to you if you only wait for a publish end event or if you really want to know what's happening and if there's maybe any failing events or other status updates. But be aware, and this might be a little bit of a bold statement, but don't trust webhooks. The delivery is not guaranteed. And also not the order. So you might receiving the events in a different order. If you really want to create business critical integrations, you're better off using Sitecore Connect actually. Still, if you decide to use it, and you can perfectly do it, and I'll show it in my example as well, make sure that you prevent data loss by designing for error. Like you might not retrieve certain webhook events, and your code should be resilient to cope with that. I'll show you what that means in a minute. And make sure to always allow for retriggering processes, which also means that you can have duplicate events. Like if there's a workflow and it fails at some point and you start it over, you might go over some code that initially created an item in Sitecore, for example, or something else, and you want to check and then update the item instead of creating another one. So that's what they call idempotent. So you want to have your all of your steps in your process to work the same for every single situation, or maybe multiple runs of the same code. And the last one is the search options that you have. And I think this warrants a completely different talk. But I wanted to just briefly show you the options and why I chose the fourth option in this row and what you can do in certain situations. So you have, in the past we used Solar, and while XM Cloud is still using Solar in the background, it's no longer open for you to use your own indexes on. So that's not an option. If you have a more content-focused need, then you can use Sitecore Search, and I absolutely endorse that tool. It's great, and it gives you a lot of functionality that you do not have to maintain yourself. If you have a more e-commerce-like focused search need, like searching through products, you can use Sitecore Discover. But you can also use your own, and obviously you can have your own Solar instance completely separate from Sitecore, obviously, but this is more like PaaS solution. You can use, for example, Azure Cognitive Search if you have like custom entities that you want to search through. And that's what I'm also going to show you in my example. So there's a few, you have to select your components, but there's also a few design considerations you have to do when building for resiliency in such a composable cloud landscape. When you have selected your component, you want to start with designing the APIs and the contracts between all of the components. Make sure that everything is stateless, and introduce something like event sourcing or a pub/sub pattern, because you want to be able to as I said, you want to be able to refire certain events, or you want to keep the state when other systems designed for error are not available. And you have to make sure that you have a good idea of what the governance of your whole application landscape is, because it's not going to be the same as for a monolith, even running on a Sitecore XP instance. You own everything, and you decide when it's get deployed, when it get updated. But in a composable scenario, that's no longer the case. So you have to know which level of control over each component you have. And with that also comes latency. And there for sure is going to be latency in your landscape, and you have to cope with that as well. All the things I'm now showing and telling you are in an example that I'm leading up to, where I show how we made our way around these challenges. But there's also, I think, 4 challenges or 4 things that I want to point out in particular that are very important. And this might be very obvious, but authentication and authorization is one of them. Your users interact with the front-end app only, and where if your only connection is with with Sitecore or with XM Cloud in that sense, then if a user is going to log in or identify himself, then that's valid for his whole session. But in a composable architecture with microservices and other services, which isn't isolated, you should treat every bit of traffic as being public. So you have to secure all of your endpoints, and you want to have a centralized identity access management system. And for example, Auth0 or Microsoft Entra is one of the examples you can use for that. And so be sure not to introduce microservices that you call directly from the front end that do not validate the login of your user. And the next one is volatility. In the past, when you had your full governance of your own implementation, you were kind of sure that between deployments, your production environment was completely stable. Because you didn't deploy, nothing changed, and apart from the occasional incidents and issues that you might have, this is stable between releases. But when you start using and combining different models, like your own microservice, your own deployment with XM Cloud, for example, as a SaaS product, then you start introducing dependencies on other release cycles. And you do not control them, so there's no guarantee that they are either going to introduce new changes. And of course, they promise not to be breaking anything, and there's not going to be introduced any breaking changes. And that probably is true, but it could very well be that some things that you are doing are impacted when there's new functionality. And my reasoning is that when they are able to fix bugs in production without you having to touch anything, it might potentially also mean that it's also possible the other way around. So you have to to take that into consideration, and that means that we use tooling like Cypress and Application Insights for that. You do not only test your software upon release, but continuously on production. So pick out your top maybe 7 flows on your website or your portal or anything you're building online, and make sure that you monitor them regularly. Of course, you can look at the release notes and you know when stuff is released of your dependencies, but there's no proof like just testing it continuously on your own website. And another challenge when going composable is traceability. You have a lot of components, different tools, with different types of logging, different types of, logging in to actually be an admin and administer the tool. And that means that it's very important to be able to efficiently follow requests and data through those flows to identify issues and potential performance leaks. Also, and that's what they call, by the way, distributed tracing. So you have some kind of tool that allows you to see where a request is going when you pass it through different components of your composable landscape. You also want to collect your logs in a centralized environment, like a logging tool, and make sure that there's one unified way of observing what's going on in your complete architecture. If you have a technical application management team that needs to log in onto XM Cloud and maybe some other component as well, and then you have your microservice that's pushing your logs to, I don't know, a data store in Azure or something, then it's very difficult to find what's going on when something goes wrong on your production environment. And the last thing is that you want to take into account that messages do not always make it to the other service that you're calling. So you might introduce some things like, and they are, generic service bus and queuing principles, but something like a dead letter queue, and also design a process to do something with what ends up on your dead letter queue. And there's multiple tools like Sumo we have used, but you can also use Dynatrace or Azure Service Bus, for example, to cope with these challenges. Last one is version dependency. Obviously, you want to avoid strong dependencies between those components, but you also want to have the ability to individually deploy all of those components to limit risk, impact, but also to increase your maintainability and agility. And that means that you also want to be able to roll back those components. So you should have a certain frame in versions where every single component is able to communicate with all the other versions of all the other components. And that is why API versioning is indispensable, and you have to have a deprecation strategy to know what versions of which component is working with which version. So that's a whole lot of theory. Let's, and I'm not going to live demo, but I'm going to show you a use case to make it a little bit more, visible in how we cope with this in a practical scenario. I have a use case where I'm using XM Cloud with a Next.js frontend, and I have a third-party product API. You would say, oh, Discover, or maybe maybe you have an e-commerce tool to manage those products. But this customer already has their own e-commerce solution to manage the products, and it's a very low product count. So it doesn't really justify buying an e-commerce tool for that. But I still want to be able to search through that. And this is a requirement from the SEO team. They want to have a single physical page in the CMS for each product, so you don't have wildcard URLs or numbers and stuff. They really want an actual page in it. And on top of that, the product API that our customer has, we've been integrating with, doesn't offer search query. So I only can retrieve a product based on its ID, but I can't do like a search query. So now I'm like kind of stuck because I want to be able to search in my front end, but I need to, and I also need to push my data into Sitecore. So this is one of the scenarios that we actually decided to push all the content from the product API into Sitecore, at least to create a sort of representing items. I've also built e-commerce solutions, custom e-commerce solutions, where we had tens of thousands of items and or products, and then of course we're just going to use them directly from the front end, from the external API, but in this case not. So we came up with a design, an architecture for this, and we've made a few design choices. The first one is that we actually only want single-purpose microservices to build integrations, and only have one external dependency per microservice. So like if you're pulling data from an external microservice and you need to wait for an other to be available or send a message over, then you're going to lose the data if the other dependency is not available. So it'll get clear when you see the picture. I want to minimize data redundancy, so I don't want to carelessly copy all of the data over all of my components. And I also want to, as I said, prevent data loss. And retriggering events should be possible. So I want to have kind of something like called replayability. So I want to be able to replay parts of my data flow or my workflow to restore a situation where something got stuck or didn't proceed. And I also want to have everything idempotent. So processing the same event twice shouldn't have a negative impact. As I said, you want to either create or update an event when you get an event twice. If you hook on a webhook of a publish event and your content editor is like repetitively pushing publish because he doesn't see the item yet and he thinks, where is my item? Where is my page? Then you will get multiple events that do exactly the same. You want to allow for that. So let's start building the architecture. And I have these gray areas of software that is not governed by me. On the left side, we have the API from our customer, which is actually a Kafka instance, a messaging broker, which I can subscribe to certain topics to retrieve updates of products. And I have a product API that I can request product data from. On the other hand, I have Sitecore XM Cloud, which this is a very rudimentary design of what is actually under the hood, but the most important components is that I have my XM Cloud instance, I have Edge, and the data is stored somewhere, but I don't really care. And I have my Next.js headless front end, of course. Everything that's appearing in the white is governed by me or owned by us. So the first thing I start doing is create a product microservice, which subscribes to the Kafka topic. And when I get an update that a certain a certain product is updated, I retrieve that data from the product API. And this already is a very good example because I have no way to influence retriggering an event coming from Kafka. If I miss this event or it gets lost, then I can't replay it. I can't ask to have that event again. And as you can see, I would have been able to directly push that to Sitecore using Graph, but then when the events get lost, my data gets lost. So that's my way, and I don't think it's redundancy in any way, but to create a service bus that I own myself where I can queue this item that I retrieved from externally, and now I have only one external dependency in this microservice. And then I can utilize the authoring API to introduce another a microservice that retrieves the data from my queue and puts it into Sitecore. And again, only one dependency. And in this case, if Sitecore for any reason is down or slow, then I don't lose my event data, my new product data. And on the other hand, if there's maybe, I don't know, well, actually, we've seen this. It's only not many products that we have. So we've built this, and we unknowingly tested the publishing capabilities of Sitecore XM Cloud because the customer kind of accidentally forgot to tell us that with the product API that they have also comes like contact data, and that contact data includes like a whole history of contacts that aren't even used anymore. So from one day to the next day, we got like 40,000 events on our service bus, and Sitecore took a little bit of time to process all of that data, and especially the publishing, obviously, because and that was, in my opinion, a design error from us, at least, working with this customer. So we quickly adapted this process that we wouldn't process these types of events. But you can see that you build in resiliency when you split this out in separate microservices, and all of those microservices will be very simple. They will be very clean, and you can quite easily maintain and deploy them. And you can also deploy them separately because you have the separation of the queue in between. So then Sitecore publishes this new content item, and we're back to our original limited set of products, and it publishes it to Edge. But also, we want to have the ability to search. So what we decided to do is we decided to have a product index in cognitive search to create our facet filters in the front end to do the searching, and then query on that for our search result. And when you click on a search result, then you go to the actual page in Sitecore. So now we have best of both worlds. We didn't query on Sitecore, we can create custom facets and all kind of stuff, but we still have pages for all of the components. And to populate that, following our own principle, we created another microservice and another queue to lead that into our cognitive search, because we've thought of this as being an external dependency from our own microservices. Now, this means we do no longer have to push integrations and business logic on Sitecore anymore, focusing our ownership on our own microservices and front end, and I think that makes development more fun and easier without any strong dependencies on Sitecore. But the governance in this model really helps in achieving maintainability, scalability, and agility. And it also makes a better and more resilient architecture. But we have to take a few things into account, because if you zoom into this part, there's something funny happening. And that is this route is going through all of our own resources and code, and it does only manage and handle only one entity type, a product update. And that means that it's very quick. We have full autonomy over it, opposed to this route. Because, well, our event might pile up with a content editor doing a full site publish, or there may be a lot of items published. So actually, and we've seen this in practice too, but this route is always slower than the green route. And what that means is, well, we do not control this process. We can't control it, so that's what I said in my explanation, that you have to take care of or take into account the governance of your model. But it's also queued with a whole lot of other events. And this means that if you now search on our front end, you will find search results that contain a certain product, but when you click on it, it's not yet available, so you get a 404. And what we did to solve this is add a webhook. Add a webhook to wait for the notification of the item being published and then make it available. But if we, in this case, would have waited for the webhook before we push data to cognitive search, we might again lose the data because, well, we're waiting on a second dependency. So what we did is, and this can also be as slow as the other publishing, of course, we've added a flag in our cognitive search. So we immediately push data to cognitive search, but said it's not published yet, and then introduce a publish flag so that we can, in our search query, very easily search for only published products. And this way, it's a repeatable process too, by the way, because if the webhook never comes, then I can just go into the CMS and click on publish again, and it will validate, in a way, the cognitive search entry, and it will make my item available again. So it's repeatable. And what you see is that we have a very resilient way and very of integrating with Sitecore. We have nothing deployed to Sitecore at all of our own custom code. We've still done all the things that we did in the past, like creating search, editing items, and we have a lot of, well, single, well-maintainable microservices that we can deploy, each in their own pace. And that's what we ended up with: scalability, agile, and I think a true cloud-native resilient integration. So it's time to go to the conclusion. Sorry, did I miss something? Okay, sorry. And that's, well, actually, our lessons learned are that you don't want to customize anything on your Sitecore instance. You don't want to have to deploy custom code to it. And you want to try to only use out-of-the-box configuration and integrations. Maximize the utilization of your cloud-native and composable components when you design an architecture, and prioritize resiliency. And by that I mean allow for queuing, be sure that all of your components are idempotent in handling data, design for error, and last but not least, make your items, your components, cross-version compatible with all of the other components in your landscape. And with that, I want to thank you for your attention. And if you have any questions left, then please go ahead.
Thank you very much for this presentation, Rob. Actually, lots of things you shared I learned the hard way. So the question I have relates to the first part of your presentation. So you mentioned centralized login systems. So what would be your best suggestions from your experience and pros and cons?
Good question. I don't have seen a whole lot of different solutions to that myself. We use logs because it's fairly easy and easy to integrate with. So if you're from a developer approach, that's what we use. And in another situation, we use Sumo because it's automatically integrated with all of the Azure components. So we actually do not have to configure anything ourselves. It just allows for automatically retrieving that data. But I would probably look into either logs or maybe application insights, but then everything has to run basically in Azure, so that may not be your case. And otherwise, that's probably it, I guess. Yeah.
Thank you.
Hey Rob, thanks for the presentation, really great. I have a question about can you pull back 2 slides? It makes it easier to talk. With the overview of the whole solution.
Yeah. This one?
Well, actually 3, sorry. You have the microservice at the top. It now has 2 dependencies, right? One on the search index queue and on the XM Cloud on publish.
Yeah, but well, the on publish event is how do you say that? Yeah, if it doesn't arrive, I don't lose my data. So it's only a trigger from externally to. In a sense, you're right, but I designed it like this, so I never lose my data. And for some reason, or for one way or the other, I have to allow for a webhook to notify me. What you also could do, but then you're getting maybe a huge component count, is introducing another microservice that updates the cognitive search. But the funny thing is that some people say that composability breaks up a monolith into a more manageable and less complex ecosystem. But the thing is, what I think is the biggest pitfall of composability is a complex ecosystem, because this can get out of hand. So sometimes you have to find the right sweet spot, and if data is not lost, then I think this will work with our, but well spotted, yeah.
Yeah, well, I think the search microservice could also be just combined with the Sitecore microservice as one entity, so that you always have
yeah.
Because then, at least if it's failing in your CMS update, it will also not go into your product index.
Yeah.
Also not resulting in a 404, of course.
Yeah. But we have some. The thing is that we push some additional things to the product index in this case, which yeah.
That makes sense. But thanks.
One more from me relates to this diagram. So, is there any particular reason you use the webhook from CMS rather than from Experience Edge? Because in my experience, there might be delay after you published everything. There might be still a minute or so for synchronization on the Edge side. So Edge webhook will give you the genuine status.
You're right. This is just the way I drew it, but you're right. It's actually coming from Edge.
Question here on the data event topic on the cover broker. What are you running on the layer? Are you updating the product, or are you updating an item on the product?
Well, for us, the product is a Sitecore item, and
Okay, so that's so always transporting the entire item on the products.
well, that's the thing is that the Kafka only notifies us with an ID. Then we retrieve the full data, and then we have to find a way to update.
Okay.
And in our first version, we pushed all data into Sitecore. But if there's a lot of events, you get a lot of different updates. So now we have we kind of create a shallow page, which is more of a reference, and only the data that needs to be managed or edited by content editors is going to be actual fields in Sitecore, and the rest is a JSON blob.
So all the structured data, structural content, basically will be filled in. And you update then the entire product for the
item, and we update the index, and then when everything's ready, we push it to next. Yeah.
Thank you.